Hurricane Grace is back.
So that's a multi-hazard storm. So what can we do before the event?
Your structure is now more like a balloon.
This is a really hard experiment to do.
Water is 1,000 times heavier than air. They are reproducing large-scale phenomena of the ocean, but there is some limits.
We know wind and water can knock a home over. But for those that still stand, what physics, chemistry, and microbiology might be at work.
If this was just a typical home show, we would just mop up the mess and replace the windows and the drywall and do a thrilling reveal of the rehab.
Let's be more interesting. The Science of Homes goes deep on this one, and we'll hear about the latest research on hurricanes, tornadoes, tsunamis, and floods.
And even the latest building codes might fall short of preventing our disasters.
It's the shields we build. And the risks we take. It's the disasters that will test us. And what will grow from them. It's real life. And the physics, chemistry, and microbiology of the science of homes.
When you get a huge amount of water into a home, or you have a really humid environment inside a house, then what happens? There's a whole world of microbiology that people think about, but there is also the potential for a huge amount of chemistry to occur. So when you add really high humidity, you're gonna make water films. And you've seen this when you have a really humid day and you get water condensation perhaps on the glass or inside your home. So this is the experiment that we've done at CASA. So we have pumped up the humidity of the house to 75% for several days in a row and watched the chemistry. You can visibly see the water films forming inside the house. It looks like the house is sweating. We suddenly see not just the chemistry on the organic surfaces of the homes and on the paints, but we're suddenly creating this film of chemistry that can act just like a glass of water, but with a huge surface area. So we have this massive water film inside the house, gases that are soluble, so things that can move into that water film, will all tend to move out of the gas phase and onto that water surface. So we can watch them move by measuring the chemistry in the air. And then you get reactions inside that water film, and then we can see that pump out new and different chemicals. This is a really hard experiment to do, but I think it's really relevant because with flooding events and with hurricanes, and these events are only going to increase with climate change, they already are, we're seeing more and more water in homes that is changing the composition of the air that we are breathing just by adding water.
So hurricanes, we have wind, we have rain, we have wind-driven rain, we have storm surge, and we have flooding. So that's a multi-hazard storm. The thing with hurricanes and tornadoes, because tornadoes are often also in the middle of severe storms where there's rain involved, is both of these types of wind events do create enough uplift that you see damage on the roof. And that's a lot, again, because we're not designing to prevent that uplift. And so when you have that uplift on the roof, you see the roof shingles start to come off. You might see roof panels start to come off. You might see windows get broken by windborne debris. So that's another important part of the hazard combination of these types of storms too, is the windborne debris that's creating missiles on our homes. So now when you have damage to your windows, damage to your roof, and then it rains, and that water gets inside, now it's gone from being a structural problem on the roof that maybe could have been fixed. Once you've got all that water damage, everything's completely lost. Inland flooding is becoming a really big problem in the United States. And I do think it's taken a lot of researchers, a lot of policymakers off guard. because when we think about flooding, we think about coastal flooding. So back in 2016, Hurricane Matthew hit the east coast of the United States and devastated parts of North Carolina in particular. When that happened, we were able to mobilize and start a field study in Lumberton, North Carolina. We've gone back to Lumberton 6 times now, and we're planning one more field trip before the end of this project. So that's really special. Longitudinal studies that last for more than one time point is special. More than 2 time points is extremely rare. And to the best of my team's knowledge, which there's about 100 of us, there's no one else who has data like this. We survey the same 567 households every time, and then there's 350 businesses. Many of the houses are still vacant. They've been abandoned. We recorded somewhere close to 20% of our sample is abandoned housing. The public housing, as of the last time we did our study, had not been rebuilt. Actually, what's really special about that community too, unfortunately, special about them, that was 2016 with Hurricane Matthew. In 2018, they were catastrophically flooded again by Hurricane Florence. And then we all know what happened in 2020 with the COVID-19 pandemic. So this community represents what's likely to be a new norm of being hit by repeated disaster before you're able to recover from the previous disaster.